Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on Python again. And in this video, we will talk about creating join plots. Join plot is a plot to visualize the relationship between two parameters. Okay, we will use our previous file. So you see in our previous videos, we use pandas, matplotlib.pyplot, and we also use seaborn, and we do the drive mounting to connect our Google Colab with the Google Drive. Inside the Google Drive, we have stored a file in which we have the data. Okay, and this is the path connecting the Google Colab with the data. The data is actually an Excel file, and this is the table data frame. So it's a production monitoring table. We have oil flow rate, water flow rate, separator pressure, and also choke opening. And this is the headers of our table. So as you can see, we have oil flow rate, water flow rate, gas flow rate, wellhead pressure, and so on and so forth. And actually in the previous video, we created distribution plot. Okay, frequency versus the oil flow rate. Okay, so you can see the range of our flow rate is around from 200 BOPD to 8,000 BOPD. And this is the frequency of the occurrence of this oil flow rate. And in this video, we will create join plot. And this is quite easy. So you can follow me. We make a new line of code, maximize. So to create join plot, we will use seaborn SNS. We call our seaborn as SNS dot join plot. So you can see this one. You can click join plot, open parenthesis. Now we call the table, which we call df. Okay, this is the code. Df is using pandas to read the Excel file, and the Excel file is the path. Okay, and the path is actually connected to our Excel file. All right, so I will create this join plot from this df. That's why we make this one df. And let's say I want to see the correlation between the choke opening with oil flow rate. It's quite easy to understand the correlation between them. As we increase the choke opening, of course, the oil flow rate will also increase. So let's see this one. And we call the name of the parameter, which is actually this one, choke in, comma, okay, df again, okay, and then oil flow rate, and then the color. All right, the color I want to be blue, and the kind of the plot I want it to be scatter plot. All right, so you can see SNS dot join plot, the first parameter, the independent variable is the choke in, and let's say the dependent variable is the oil flow rate, and this is the color, and the type of the join plot is scatter plot. Okay, so we run. All right, very easy, right? So you can see in the vertical axis, the dependent variable is the oil flow rate, and the x-axis is the choke opening as the independent variable. And as you can see, we can see the trend, right? As we increase the choke opening, as we open the choke, the oil flow rate will increase, right? That's quite easy to understand. Okay. And let's see about the connection between this wellhead pressure and let's say the water flow rate. Okay. So we make a new line of code. the same thing, actually, the syntax. So we can copy. And now here we will call the wellhead pressure in PSIA and the water flow rate in barrel water per day. And I want the color to be green. And kind is the, let's say, KDE, kernel density estimate. And can you guess how the result will be? Yeah, as the wellhead pressure is increased, the water flow rate will decrease. Why? Because if we have high wellhead pressure, it is actually a back pressure, a high back pressure. And the back pressure will restrict the production. So as the wellhead pressure increases, the water flow rate trend will decrease. Okay, so let's run and see. Right, this is the joint plot with KDE as the type of the plot. KDE is the kernel density estimate. And as you can see, as the wellhead pressure increases, okay, from around 1000 to 4000, the water flow rate will decrease, okay? Because as the wellhead pressure is increased, the back pressure is increased, and the back pressure will limit the production. All right. And now let's see the connection between the bottom hole pressure and wellhead pressure. And of course, it is quite easy to predict. As the bottom hole pressure increases, the wellhead pressure normally will also increase. Okay, let's check it out. Code, copy. All right. And then I want to change it to be BHP, bottom hole pressure. And this one I want to change to wellhead pressure. I want the color to be purple. Okay. And I want the kind to be hexagonal, HEX. Okay, let's run. All right, very easy. We have a purple joint plot. And as you can see, as the bottom hole pressure increases, the wellhead pressure will also increase. Okay, and we use the hexagonal plot. All right, I think it is quite easy to understand. So let's call it a day. In this video, we have created joint plots using Seaborn as our library, and we created scatter plot, KDE plot, and hexagonal plot. All right, I hope you enjoyed the video. I hope the video is useful. Thank you so much for watching, and please don't forget to subscribe, like, and share to your friends, and see you again in the next Python videos. Thank you.